maybe Tharek, we'll start with you, but one of the things we always like to talk about is, and I'm sure when we talk about to our non-engineering friends about what we do, they say, give me an example of how this thing works, or give me the use case. So from your perspective, what's your canonical use case or favorite deployment that you've had, or favorite device that kind of encapsulates this embodied intelligence?
Yes, we at BrainChip, we have this customer called Onsor. It speaks to me because these glasses, they have EEG electrodes on them, so it captures brain signal, right? And so it's used by epilepsy patients so that they can detect when an onset of epilepsy is happening, which is truly a useful use case for me. And why I feel like this is an embodied use case, it speaks to me because it's constrained due to the latency, because you need to know very quickly as soon as the epileptic seizure is happening. That's number one. That's a latency aspect of it. The second is it's a glass form factor, so that you want to be able to charge it in a reasonable amount of time, maybe every few days or rather than every few hours or so. So it's constrained from a power budget perspective as well. And it's running AI on the edge. So from that perspective, it's embodied for me, right? Yeah, typically people think of embodied as robotics or autonomous vehicles, but even things like medical devices like glasses and things that run on the edge in a constrained fashion with a low power budget in my opinion.
MedTech is definitely a hot area for this stuff, the kind of wearables, hearables, implantables. That's a big area where you need that low latency, low power for sure, low cost too, for a certain extent. But Shreyas, what's your go-to?
Yeah, so I've got two examples that I wanted to share here. One of them, which is fall detection in homes, particularly in elderly care. So we use radar to detect fall detection, and of course we process it through the spiky neural networks and make it really efficient. The key thing here is that why I call it embodied intelligence, because the place you need the most to detect a person falling is actually your back. Can you have a camera there? No. You're going for a shower, you probably removed all of your wearables that you're wearing to detect fall. You cannot rely on that as well. So what is this most secure, private thing that you can install in your bathroom to detect a fall? And this is a use case that is quite dear to us, and we have solutions there where with the radar-based presence sensing, you can actually detect an elderly person falling in, which is, again, like you said, it's quite a life-changing use case. And the second one that comes to my mind, of course, is from the space, and we've been working with partners of ours who develop these artificial fingers and artificial hand. And before they came to us, they were running a large language model, million-plus parameter model onto large GPUs to detect the materials, to detect whether the grip of that hand is correct or not. And with our Pulsar chip, now they have been able to run that in low sub-milliwatt power, that entire model. And because of the very low latency, because you don't have to loop it through the cloud, you can now get very reflex-based actions on the arm. Those are two use cases that come to my mind.
Yeah, those are good ones, yeah. Scott, go for it.
Yeah, so at EMAP, we're pursuing the applications that we're talking about here in wearables, IoT devices, where we want to do make more decisions, take more actions on device, battery-powered devices, allow the system to go to sleep and then wake up only when it needs to, right? One of the applications we're pursuing that's unique is in drones. So drones you don't think of as, okay, it's going to sleep, right? It's flying all the time. The flight controller is active all the time. Is there a way that we can insert an always-on inference system in there to help with efficiency? And so that's what we're doing is drones have a bunch of sensors. They got the IMU, GPS, imaging. So we're ingesting all that sensor data before the flight controller, running some AI models in a control loop to make minor adjustments to the flight controller to improve the efficiency of the drone. Through simulations, we've done over 300 simulations, is that we can improve efficiency by 60%. And when I say efficiency, that means flight time. So 60% flight time in a drone that's running on a battery, that's huge. We talk about commercial world delivery drones, surveying drones, even in the defense sector running missions. There's a huge amount of value to have more time to do whatever you're doing on the drone. So That's one where we're trying to extend this always-on inference from let's take actions on a device, put things to sleep, to how do we actually improve the performance of a autonomous system.
Yeah, makes sense. So Abdullah, I mentioned before you're wearing these glasses. You're living the dream here with your wearables. So why don't you give us I can guess what your use case is, but surprise me.
I forgot about the glasses. And that's actually the technology that I love the most. The technology that you forget about. The technology that disappears in the background, but it still helps you. When computers came out, I had a lot of family members. They were overwhelmed. They didn't know what to do with computer. When AI is coming out, it's supposed to be easy for people. A lot of people wear glasses, so I'm wearing glasses. If a phone call comes in, I just speak, yes, pick it up. I start speaking. No matter where I am, the noise in the background gets canceled. Nobody can hear the background noise. Glasses can become more smart, where I'm not even on a phone call, but I'm talking to you, and now your voice will be amplified in my glasses, and everyone else will be completely isolated away, so I can have a conversation with you. All of this is happening. I'm not pressing buttons. I'm not doing anything. It's just disappeared into the background. It's helping my life. That's a technology that I really like.
Yeah, that's a good characterization, is the technology that can disappear is sometimes the most valuable stuff, right? So it's cool. So Steve, what's your canonical use case, show off case study thing?
So I actually have several, but I'll just pick two of my favorite.
Okay.
Of course, besides wearable, I think one is an endoscopic capsule where they needed a very small footprint, and where Himax HAI chip is 3 by 5 millimeter that fits right in. And they needed something that's low power that can continuous to capture image through the whole 8 hour of the activities in a patient's gut, right? So we're able to maintain low power, constantly capturing images, and also use AI to interface with the IMUs to know where the location of the capsules in the gut. So that really display our use cases in low power, at the same time being very efficient in sensor fusion.
Yeah.
Another use case would be in wildlife preservation, where they're embedding our AI chip into preservation of wildlife in Africa, rainforests in South America. They needed something, again, camera very small. At the same time, it needs to last 10 years of battery life, because once you place it out in the wild, there's no one that goes out can replace the battery, right? And the reason for it being small, because they need to, if it's too big, the poacher will come and they will just take it away and then destroy it, and that defeats the whole purpose of preservation. And again, they needed something that's low power, that can continuous capture image, accurate detection, can differentiate between human, animal, because you don't want to keep triggering when there's animal walking by. These are the two of the favorite use cases that Himax has been very proudly participating.